Welcome to another episode of Brains Behind AI. And today on the show, we have James Pryor. James is the Senior Director of Product Marketing Communications at SiFive, the industry leader in RISC-V processors and silicon solutions, where he leads global communications for the company, helping to plan and manage product and corporate marketing. Before SiFive, James worked at AMD as part of the client product management and business development team, helping to define and launch the Ryzen Threadripper HEDT and Ryzen desktop processors. Previously, James has covered technology companies as a journalist and worked in the university data center as a systems programmer for smart grid operations. James received his degree in electrical and electronic engineering from the University of Portsmouth, UK. James, welcome to the show.
Thank you. Pleasure to be here. Thanks so much for having me on.
Hey, James, before we dive into your background and the company, can you take a minute to let our audience know what SiFive is in sort of layman terms? What do you do as a company?
For sure, yeah. So SiFive was founded by the inventors of RISC-V, which is a new instruction set architecture. And that's the specification that tells the computer hardware how to talk with the software. So whenever you write an application, you are doing it inside the confines of the instruction set architecture, the ISA, and telling the machine, go do this. So there's lots of different ones of those. RISC-V was invented at UC Berkeley in 2010 as researchers there were trying to figure out new ways to make the computers more efficient, more programmable, more flexible. And there wasn't something on the market that they could just go use because of proprietary licensing agreements and expense. So RISC-V is a free and open specification that is developed by the RISC-V International Organization, which is made up of a bunch of different technology companies, researchers, universities. It's like a who's who of technology. And they guide the RISC-V specification and the extensions to make the set of instructions and basically the manual for how to build computers for anyone who wants to use them. And SiFive is exploring the commercial opportunities that RISC-V instruction set allows. So we create microarchitectures, processor cores, and accelerator IP that other companies can license from us to build cool SoCs and solve different problems for their different solutions. We've had a lot of success in the embedded market, and now we're moving into the application and AI markets with new, higher performance, more efficient accelerated designs.
Excellent. That's very impressive. Now, James, how did you find your way to SiFive? What was your journey like?
Yeah, so that's an interesting one. So I was previously working at AMD and had been doing some great work there with the Ryzen team and the client business unit. And we disrupted our competitors' approach to the market with new definitions, new products, new performance, new approach to it. And I was kind of wanting to extend that theme, and I bumped into a guy on an airplane. It was one of those things, you travel around the world, you never know who you're going to see at the airport. And I bumped into a guy and he's like, hey, we should talk. I'm doing something fun. You might like to do it too. And one thing led to another. I ended up joining SiFive as they're off trying to move and disrupt the industry from proprietary legacy architectures that are bogged down with lots and lots of history and lots of inherent issues for something cleaner, lighter, more sophisticated, but simpler at the same time. And I thought, well, that sounds fun. Let's go give that a shot. And here I am.
There we go. So how long, when was SiFive founded and when did you join? Have you been there since the start? When did you get in?
No, I got in pretty early in 2019. SiFive was founded in 2015, so we're just over 6 years old now. So I got in at around the 4-year mark or thereabouts, 4.5. So just as it was starting to ramp up, I've seen this hit 200 design wins with 7 of the top 10 semiconductor companies, as well as shipping 1 billion cores across the globe. So it's really early days, but already a lot of success, and we're really listening to what the market needs as we watch the explosion of AI both software and hardware happen around us.
Amazing.
Wow. And how did the company come up with the name SiFive? What does that mean exactly?
Well, they invented RISC-V. RISC goes all the way back to the early days of Hennessy Patterson, well known in the computer architecture space, awarded the Turing Award for their contributions to computer science over the years. So RISC stands for Reduced Instruction Set Computing. This is the fifth iteration, because there was a RISC-1, a RISC-2, 3 and 4 were kind of named somewhat different, but when they invented the fifth one, they were like, okay, we need to make the family work. So RISC-V, and instead of using the number 5, they used the numeral. So that's why it looks like RISC-V when it's written down, but it's really RISC-V. And then because SiFive was all about the inventors of RISC-V founding a company to make the most of the commercial opportunity, then SI is the symbol for silicon, and V is 5, so SiFive, but spelled out this time. It's all about making RISC-V real and making those cores, making those chips. So SiFive, primarily licensing IP is the business model, but we also have a business unit called OpenFive that will take your design specification and work with a foundry to build a chip. And we are full service. We can go from specification through to SoC, or we can provide SoC IP or interfaces or memory interconnects or processor cores. Very broad range and portfolio, probably the broadest in the industry for our size company.
Wow, thank you.
That's great. And we're an AI podcast, right? And I was very intrigued to have you on because you're one of the first hardware in AI play startups that we are meeting. So can you, James, take a minute to elaborate how the chip and the work that you're doing at SiFive can potentially support AI? What is the role your chip's playing?
Yeah, so I think if you look at the industry trends, then it's pretty clear that what got us so far of a general purpose CPU and a general purpose GPU has done a great job of kickstarting AI and making it into something real. But the next level of power, efficiency, and performance is going to come from a customized solution. So we're seeing this development of custom silicon across all areas of the industry. You've got places like Google and Amazon designing their own chips because they want increased efficiency, increased performance. They want to accelerate specific parts of the workload. So that's where we kind of looked at it and said, we need to take a software first look at this. What are the people who are writing AI trying to accelerate? What are their commonalities? How much flexibility do they need? Because the big problem you've got right now is if you create an AI model and you say, great, I'm going to go put this into silicon and make it go really fast, you'll be able to do that. But by the time you've built your chip, the model has changed because the silicon cycle is years and the model cycle is months. So you need a programmable, flexible solution with a little bit of generality, but still the workload acceleration. And as we're moving from CNN and DNN type models into transformer models, then you need that style particular set of instructions and data types to be able to be processed, as well as the fixed function things that you're going to do inside of your graph inside the core for compute acceleration. So it's really taking a look at what are the standards that are going to win out, that are open and available to everybody. Things like TensorFlow Lite, things like everyone's writing their software and compiling it with a standard library. That approach is going to be more scalable and long-term versus doing a bespoke architecture with specific software on top of it, because even your own next generation is going to break that model. So you've got to get that added piece of it of generality. So that's what we did when we worked with TensTorrent. We're part of their second generation of AI computers using our SiFive Intelligence X280 core in their chip to help with pre and post data processing. We've got the right data types, we've got the general purpose compute, but we're right there beside the compute execution units of their bespoke AI. So it's that blend, that customization. That's really where the hardware is going. Is it's not going to be, hey, just buy a SiFive chip. It's going to be co-design your chip with SiFive so that you've got the software, the hardware, everything put together in the right place, and the flexibility to accommodate new things that you learn from your data over time.
Yeah, no, that's great. And actually, that leads to my next question. I wanted to understand, who are your target customers? Are they the companies where you design the chip together with them, or is it sort of a turnkey where you take the chip and they take your chip and run with it? How does what does that look like? What is your market?
That's a great question. So actually, it's a little bit of both. So we primarily focus on selling the IP to companies who want to go design a chip. They've done it a few times themselves. They're aware of it. They want to go and integrate IP. But we can also create platforms like we did with Samsung and TSMC, where we've built some reference platforms where it's just ready for the third-party IP to come in, but everything else is there. So we built an AI SoC model with TSMC and with Samsung that you can now come in if you're not an experienced chip company, leverage all the work we've done and build something with just the added uniqueness that you want to integrate. So broad offering, we can talk to the guys that are sitting there saying, you know, I've got this great software stack, but I want to move it from the general purpose compute or the accelerators available today into something vertically integrated myself to maximize my opportunity. And we can talk to the guys that are already doing that and help them accelerate their roadmaps as well.
Understood. Now, I'm going to sort of bring up the GPUs, the graphical processing units here for a second. I know they're heavily leveraged in AI applications because of the power they bring in for processing and compute. Now, I want to understand, if I were to draw a line, how does SiFive's work and your chips fit with that ecosystem? Is there a play or is there not a play?
Yeah, that's a great thought. So right now you've got the add-in model of, you know, you've got one or two CPUs in the server motherboard, and then you've got a you know, 4, 6, 8, I don't know how many separate GPU accelerators. And you know, there's inherent problems with the efficiency because of the delays of sending the data to each one, what amount of memory each one can address, and the compute efficiency and breaking down the problem. So what the better way to think of it is how we would integrate with that is looking at the GPU. When you're working on AI, that whole piece of silicon isn't being utilized. Only certain parts of it are. And the same goes for the CPU. It's running a specific set of instructions that doesn't change that much. So a lot of the general purpose flexibility is wasted. So it's wasted silicon. So there's an opportunity to redefine the balance. And I think you look at the industry, you'll see a lot of AI companies are moving towards a single chip solution. They've got one SoC that has multiple chiplets or tiles on it, but they're much, much closer together. They're much more integrated, even down to being inside the same silicon design, where you've got accelerators right next to the main core. And that's really where we see the big opportunity, is creating those accelerators and scaling them up so that you've got more and more compute tiles or resources or chiplets, whatever you want to call them, available to you for your workload, because it kind of simplifies how you program your models, because you've got a unified interface. It's simple and easy. You know what data types are supported, and it just kind of makes it more efficient as well as easier to program.
Mm. No, thank you. That's very interesting. And I wanted to kind of divert into the challenges now that you are experiencing, whether a day-to-day basis or just in general as a company.
Yeah, so I think our day-to-day challenges are just software, same as everybody else out there in the AI land is software. So RISC-V being a new instruction set, we're developing a new set of tools, migrating the existing set of industry-supported libraries, compilers, tool chains, And that's going really, really well. We've got some fantastic maturity in the existing tools for building chips. It's been driven out of our embedded adoption. We're seeing, mainstream Linux distributions like Ubuntu now support, you can download the RISC-V version, and that really kickstarts everything else. We've got our own SiFive unmatched board in the market for developers to get hands-on, put in their own FPGA or accelerator, whatever they want to do into the expansion slot, and begin modeling and processing their next-gen opportunities. So it's really nascent, but growing so fast, as we see with Tenstorrent and their adoption, to move into real hardware and that build the real software. So we also work with companies like the Barcelona Supercomputing Center in Europe, where they're working on the European Processor Initiative. They've adopted RISC-V and the vector extension for their AI supercomputer. And we work with them, contributing to the global software that everyone's going to use with libraries and other tools to help ensure everybody's standards and software works. So day to day, it's a lot of work on software, a lot of work on standards, a lot of work on interoperability, and a lot of work on finding out what is the important set of workload that needs to be accelerated. Keeping working on TensorFlow Lite and other models, Cafe, etc., to try and see what is the biggest amount of impact we can have to accelerate AI, whether it's in the data center as an accelerator or in an edge device or even on device in a handheld device of some kind.
Got it. So here's my next question, right? What I've seen is building a hardware company is a tough proposition, even in Silicon Valley. Most VCs run the other direction. I want to if you can just take a minute to help us explain what has been your ingredient that has helped you be so successful over the years, despite of all that stacked up against building a hardware company.
Oh, that's a great question. So I think it's a little bit of freedom and a little bit of excellence. So by freedom, I mean that we're adopting and a proponent of an open standard. So when we try to say, look, you should come use our cores, we're not building the walled garden of it only works with our stuff. We're using something that you can extend yourself, that you can hire your own team, develop yourself. And the reason for working with SiFive is because of the excellence of the offering, not the uniqueness. And that's kind of a flip on the head of everything else that everybody does in the industry, right? They try to go for, you can only get this from me. Doesn't matter how good it is, I'm the only one that's got it. Now it's everyone can have this. We're really good at it. This is, buy it on the merits. Look at our approach. Come work with us. The collaboration that we offer, the understanding and the expertise that we have of the workload, the software, your challenges. Let's work together and build that. And I think that's a refreshing new approach that's gathered a lot of momentum as we see everybody across the world adopt RISC-V. The volatility in the market that's been caused by the last 12, 18 months has really sharpened everyone's focus on, I need a RISC-V strategy. It's a strategic imperative. I've got to be able to defend my product roadmap against outside influence. And that means I need to build it on things that I can openly and freely get. So open standard software, we all know the benefits of that. And now open standards based hardware is the next level. So because RISC-V is open, it's free to adopt, and you can join the company that is making the standards and specifications and make your voice heard just as much as gigantic hyperscale companies or the biggest tech companies in the world is incredibly appealing to everybody because it levels the playing field. It lets everyone have an input on what is the best way to do this and how can I do this. And then if there's a fork, then both solutions get worked on because you can find somebody else to go do it with you. So that's, I think, the big impetus behind it, combined with the quality of our products and the relationships that we've built from our management team's experience and our awesome engineers that are just delivering great quality products every day.
Yeah, no, that makes sense. Now, I have to ask you about the semiconductor shortage we are seeing and experiencing, and everyone over ordering what they need. I want to see how does that impact you, or how do you play in that?
Yeah, so I think because we're looking at the vertical integration solution and the custom solution, the migration from off-the-shelf hardware, we're seeing an acceleration of interest because of that. Because if you're in the position that your solution is built on commodity pieces, and now that commodity has become very hard to get, you've got to bid for it, the delivery is uncertain, there's a risk in your supply chain. But if you own, like, if you're the only person that needs the chip that's being produced because it's yours, it doesn't work on anybody else's stuff, then you're in a much better position for ensuring supply. And that's the conversation that's going on, because it dovetails with the broader industry trend of let's increase efficiency, let's increase performance, so let's focus on the workload and differentiate from everybody else. And they happen to coincide at the same time. So I think that that's really driving a focus on let's build our own chip across everybody who is based on a broad platform of technology.
Yeah. So I hear a lot about sort of the dependence on China, and then U.S. working to have this semiconductor independence, right? We're making investments, and you and I are in Austin, and we know Austin's sort of a big hub there, starting with AMD and others. So what again? Do you have any thoughts? And again, don't mean to take the conversation in the political direction, but do you have any thoughts on the role US can play in helping us achieve the semiconductor independence that we should strive for here?
Yeah, well, look, it's all about a free and open market. Healthy markets are prone to growth, and that growth is driven and promoted by competition. So more and more companies being part of creating silicon, building silicon, designing it, testing it, writing software for it makes the industry stronger. So the more incentives there are to do that, then the better off the market's going to be, regardless of the political concerns that anybody might have. So it's a good thing to see the investment, because it's going to promote a lot more opportunity in the US, and for companies working with US companies to get the best technology they can find. And that's really what it's about, is providing the best solutions that you can and being able to compete fairly in the market. And this investment is going to do a lot to help to encourage that.
No, yeah, that makes sense. And how do you market the hardware and your product as well?
Yeah, so being an IP provider, then we spend a lot of time reaching out to different technology and semiconductor companies, asking them, what are the challenges you're trying to solve? What are the problems you have today? And where can we help? And that's what we try to find out, is different ways to solve these problems, whether it's a big company or a little company, and figure out, is there something on our roadmap or in our portfolio today that's going to be able to help with that, and figure out a design to work together on. So that's the flexibility of being an IP provider, is that you can really offer that flexibility and intercept the problems as they're coming down the line from the future-looking statements of product direction.
Okay, so in terms of the sectors, are you seeing it pretty well spread out? And I'm assuming your customers, for most part, are the big tech. But is there a sector that you think is more pronounced in terms of their needs and the work and investments they're making in hardware?
Well, the three big growth industries right now are automotive, and the AI accelerator in the data center, and networking, 5G networking, base station, and those solutions. Because those are the places that are seeing, double-digit growth, 30+% CAGR increase, and they have the strongest opportunities to deploy AI and make a meaningful difference in both the solution, cost, efficiency, use, and interest. So that's really where we're seeing a ton of interest. The edge AI is incredibly strong as well. They're growing and coming along. So there, I can rattle off the markets. Everything's trying to get smart, from cameras to storage, from network switches through to the accelerators inside of data centers to cars. Whether you're seeing now the strong push for integration of voice assistants and smart assistants beside the ADAS. So there is a ton of opportunity for small, medium, large scale AI in a ton of growth markets. And that's a really good place to be, because it means that you can, everyone can get a slice of pie and have a good growth without it being a zero-sum equation.
Thank you. And how big is the company? Like, how many employees do you have? Are you working with?
We're around 15 design centers across the world. We have around 550 employees. We're growing constantly. We've got a lot of open recs right now. So if you're a software engineer or a hardware engineer, then you should definitely check out SiFive in our career section. We've got some really interesting roles, especially for working on next-gen AI and fun stuff like that. So a lot of stuff going on with us. We're really excited.
Great.
That's great. Yeah, definitely. We'll direct our audience to your site to see if there's anything there that interests them. I know you're growing very rapidly. Is most of your business in US, North America based, or are you seeing more growth? You said 15 centers globally, or are you seeing the growth more outside US now?
Well, that's a good question. North America is pretty semiconductor heavy, so I think it's natural to see a lot of our business there. But there's a lot of opportunities in other geographies as well, both Europe and in Asia. So it's kind of hard to pick out one that's like dominating all the rest. I think it's fairly traditional, right? There's a strong interest in the US, strong interest in Taiwan and the Asian countries, as well as Europe.
Okay, makes sense. All right, I'm going to ask you one sort of more hypothetical question. So imagine I am an automotive industry exec and I want to make my car smarter. And I know I need to invest in the chip. So what advice would you have for me?
Well, number one is to take a solution first approach. Don't look at the technology on the shelf and say, how do I cobble that together into what I want? It's all about, what am I trying to achieve? So take the end result, work back, and come to SiFive and work with us on co-developing the technology and the chip to meet that specification and that experience. And that vertical integration will give you a differentiated and unique product that will deliver on the value proposition you want to have in the market.
Yeah.
No, thank you. And do you have any advice for maybe young entrepreneurs or just young people in general who are really looking to break into the hardware industry?
Oh, great question. Yeah. So just keep trying and finding opportunities. Say yes to things as much as you can so that you can get experience, get exposure, get well known. This industry loves to give people a helping hand. If you just got to find the right person to hold out that hand. So it's about just going to different events and participating in different technical days that you can. Just keep being around, getting the exposure, making friends, and you'll find that the opportunities start happening.
Thank you. Great advice.
Great advice, James. Hey, we want to thank you for your time. It was a great conversation. We enjoyed it, absolutely. So thank you. I know you're busy. I know you're growing fast and you have a lot going on. So we really, really appreciate you taking time and spending it with us.
You're most welcome, Ari. It was my pleasure. Thank you so much.
Thank you, James.